Okay, this is Kubernetes Container Identity for April 20, 2018. And I think we're starting with Patrick. If you can speak to your agenda item, that would be great.
Yeah, sure. Let me go ahead and paste the link over here in the chat window, just in case you don't have it in front of you. All right, so anyway, first I'll introduce myself. I'm Patrick Lang. I work over at Microsoft on the Windows Server team. Um, and, um, and I'm recently nominated as chair of SIG Windows. But basically, I've been working across all the different teams at Microsoft that are using Kubernetes and Windows and sort of helping us sort of gather all that effort into one place, along with Michael from Apprenda and our other contributors from Red Hat and Ticketmaster over there on SIG Windows. Um, and but before that, I was actually working pretty closely with Docker Inc. Um, but so just to give you some background on this proposal, um, what we've been doing in Windows Server since around I guess it was the Windows Server 2000 release. Um, all of the Windows identity that was sort of baked into the operating system, was based upon a particular implementation of Kerberos and LDAP. And so, what from a user standpoint, or rather from a developer standpoint, people were able to write apps with relatively simple APIs like, check group membership, log in as a user, impersonate, and all of those were really done in terms of Windows APIs rather than having to manually do things like retrieve Kerberos tickets and things like that. So when you take a Windows server and join it to a machine using this identity framework, it basically gets an implicit machine identity that's represented by a computer account that's there in the Active Directory. And then once you've got an app running on that server, you can do some things like just say, hey, run this as an account that is backed by an Active Directory identity. And so customers weren't typically or developers weren't typically in the habit of handling things like usernames and passwords. Instead, they would use what was sort of inherited by that process because it was launched by the OS, with that computer identity. And so as we've been working with customers that have, apps they've been developing since, around 2000, a lot of them have had this implicit assumption and been using these Windows APIs that were there. So we actually added a capability into the OCI runtime spec for Windows that let us specify a particular type of Active Directory account called a group managed service account that the container could basically assume the identity of. So it relies on the node itself, speaking in Windows Active Directory terms, to already be a member of the Active Directory forest and have that identity. And then that group managed service account is basically delegated access to that computer account, so that way it can basically get the credentials that are needed and create processes using that identity. So that way the developer never has to handle that secret. They just tell Windows, hey, start the app like this. And so we basically extended that to be able to run an entire container in the same fashion. So that's kind of the background here. And so I know that I was reading over a proposal that that Eric Chang had linked to, that was referring to using using external frameworks. In his case, or in the proposal's case, it would appear to be focused around Vault to basically get some secret material into the pod. And I think that that's a great effort, but it's a little bit different because it's still creating a file that the application has to consume rather than starting a process, with an implicit identity. I mean, I guess to put it into really simplistic terms, it's almost like, saying, run this container within this pod as this UID. where the UID is just sort of, the implicit identity that's there, or, run this container with this SE Linux label applied to it. And so, the proposal that I have for working with Active Directory is more of a configuration rather than necessarily a way of managing secrets. Um, and so, the common use cases that we have here are that when people are using things like a web app connecting to SQL, in their configuration, they can just say, use Windows integrated authentication. And then it will automatically use that machine or service account identity to try to authenticate to that SQL server. So behind the scenes, Windows takes care of all the Kerberos and all that stuff, getting the tickets. And then the SQL server on the other side will basically just check to say, is this account, within the allowed list? And then what permissions am I going to give it on which tables? So that's kind of the common way it's used. So before I go into the implementation specifics, did anybody have any questions on sort of that background there? And did you want to add anything, Ryan?
No, that was good.
And just to check, so I think the plan here is just for this is only when you're running on Windows, right? Is there a kind of an equivalent thing for if you want a Windows AD identity on Linux, or what's the?
Yeah, so this would only apply to Windows because it's specific to that OCI spec that's there. Linux applications can still use an Active Directory identity, but they have to do it by basically looking down at the schema that we've got implemented in LDAP and Kerberos and basically doing their own implementation. So it's not uncommon for a Linux app to have its own code to get the ticket and do the LDAP queries. So that way they can do things like enumerate Windows Active Directory users and machines. Like one example would be OpenShift has the capability to basically call out to Active Directory and be able to map. So if a customer already has Active Directory deployed, they can use that as the identity for assigning the roles to who has access to things in the OpenShift web console. That's one example running on Linux. But in order to do that, people are typically using some sort of libraries, whatever programming framework they're using. I know there's some common shared ones in Java, for example, that people use on Linux. But it wouldn't use this in quite the same way. They'd be running things like kinit and other stuff within the container.
What's the administrator experience of this like? What is it kind of, if I'm looking at my Active Directory, what are the kind of Kubernetes containers look like?
So the containers aren't going to be visible in Active Directory, and that's actually sort of a explicit goal that we had around this. Managing Active Directory objects is relatively expensive because that database has to be propagated across multiple machines, and there's also a latency involved there. And so, if you were to go, say I want to run an extra 20,000 containers and give each one its own object in Active Directory, that's going to put a pretty substantial load on the system. Compared to something based on OAuth or something like that, where you're just doing a simple token and querying an external service to see if it's valid. And so in this case, you would have a whole lot of pods being able to use the same group managed service account. So I may basically provision one service account that is for like the web tier of an app, and then be running 6, 8, 10 containers in that. And then if I've got another instance of that app that needs to have different access to different servers within the Active Directory domain, I give it a different service account. So it's going to be a one service account to many pods experience.
how are credentials shared through the nodes?
Yeah, so the credentials in this case, in the case of group managed service accounts, what happens is the node already has to be participating as part of a Windows Active Directory domain. So it's already got a secure channel established back to an Active Directory domain controller. And so that's encrypted. It's already authenticated and authorizations all done through Active Directory there. And then on that service Active Directory group managed service account object, there's basically an ACL that says which objects in AD are allowed to retrieve the credentials stored in that object. And so, when the Windows server has, or basically Active Directory client code knows how to retrieve those from the group managed service account, and then it basically, keeps those in secure storage on the host, and then is able to create processes and things like that as needed using those credentials that are in escrow. And actually, to give you a better idea of how the credentials are retrieved, if you look about halfway down on this doc, there's a line that says example credential spec.json. What that JSON blob is doing is basically giving enough information to be able to uniquely identify the group managed service account. And so you'll see things like, the machine account name in there, but you won't see the password because that's retrieved automatically by the node. Only after it passes authorization with the Active Directory domain.
Can you give a bit more detail on what's actually in the secret? Is it actually a secret, or is it more like a reference? Is there actually secret key material in the secret, or?
Okay, so in this proposal, what I'm proposing to do is to take that JSON blob, which doesn't contain a secret, it's only a reference to it, and that's what would be stored as a Kubernetes secret. And I'm doing that basically as a way to avoid having to put this content on all of the nodes. That's a limitation that the Docker community is living with today, but the customers aren't particularly happy with it. So the actual secret material is only stored on the Active Directory domain controller, and then it's stored in a Windows service that's built into the Windows node itself.
Got it, right.
And so that's never written to disk.
Yeah, okay, so you're using secrets as a convenience, essentially, to mount something you need into a container, rather than, and that's a trade-off between running like a daemon set or something to do that work.
Yeah, and the other thing that's different about this is this secret is not actually going to be passed into the container. It's actually going to be consumed by the host, because the container runtime on the Windows host knows how to interpret this, and it's going to retrieve that stuff automatically as it starts the container. So rather than it being a two-step process where we would, put it in tempfs and then assign that volume to the pod and then to the container, instead, this is interpreted by the OCI runtime on Windows, and it is able to get that secret, and it actually creates the processes to hold all of that material automatically. It's built in. It's not something you have to add into the container itself.
I see. And I guess because you're only doing one per node, you probably won't hit the kind of scalability problems we've seen with secrets. Whereas if it was kind of one per container or something, then you would have those same scalability problems.
Yeah, well, I wouldn't say it's necessarily one per node. It's going to be one per pod per service account. And in the typical case for a given deployment, I would expect it to have just the one service account for that pod, even if there's multiple replicas of it across the Kubernetes cluster.
Sorry, so is that if I have multiple pods sharing the same service account, are there multiple of these, or is there just one?
No, they could use the same one. And that was one of the reasons why I wanted to be able to put in the secret and be able to reference that rather than requiring people to put it in every single deployment spec that they're doing.
So one comment, or I have two comments, but first, why wouldn't you use a config map?
So a config map would be possible, but by default, they're exposed into the container. And in this case, I don't actually need the container to be aware of this info. The Windows APIs inside the container will already know what their host name and DNS name are. So it's like, if it was in a config map, I mean, that would be possible, but the application inside the container would never actually consume it directly.
I think both secrets and config maps are only exposed inside the container when they are used as a source for a volume. So you can reference config maps to say plumb a AppArmor spec or
Okay.
Reference secret for an image pull secret. And I think that it's just like an extensible mechanism for distributing configuration or secret data.
Okay.
The benefit of using a config map is they have better performance characteristics.
Okay.
Just
Yeah.
how
Okay. Yeah, no, that's great feedback. I didn't realize config maps could be used without projecting them into environment variables or volumes. Because yeah, I mean, this is very similar to the case of doing an AppArmor profile or something like that. It's extra configuration that the host needs to be able to obtain, but the contents itself don't necessarily need to be encrypted because there's no actual secret material there.
Yeah, it sounds like config map is a reasonable mechanism. The second question is, okay, is this configuration exposed through the container runtime interface, which Kubelet uses to talk to different container runtimes?
So it's currently exposed in the OCI runtime interface. It's not exposed in the CRI interface yet. In 1.10, we added the Windows resource settings in there, because if you look at the OCI spec, there's two different configuration areas, one for Windows and one for Linux, to deal with differing things like username versus UID and the different resource constraints there. So part of what I would need to do is actually to update CRI to include this extra field there that's proposed there. Looking to see if I have.
Does this need to be user specifiable? Like, is this something that a user must set or can set, but they would prefer it be automatic?
So this is something that a user can set, and it can't really be automatic because we need to know what account they want to use, and that is often going to be something that an operator may set rather than the developer.
Well, and so the reason I ask that is because when a pod is when information about a pod is passed down to the CRI, I almost really wonder whether this is more of a configuration detail of a node, even below the kubelet, where you might want to override it, but if you could come up with a mechanism that didn't correct me if I'm wrong, it sounds like the ideal outcome would be that there's a higher level mapping of the operator sets that makes these decisions, whether that's namespace to service account in AD, or whether that's service account in Kube to service account in AD, or whether it's take the service account plus namespace and do a mapping lookup someplace else. But most of those sound like details that could be done even below the CRI layer, with the opportunity potentially for maybe the administrator or a user to override it. Is that fair, or am I misunderstanding mechanism?
Yeah, so I wouldn't necessarily expect all the pods on a given node to want to use the same identity.
Not the pods on the node. So this is total hand waving just to illustrate the point. But when the CRI, which is going to go talk to Docker or whatever, that's the last point kind of that the information about the pod exists before we materialize containers. We don't pass service account to Docker, but we could. There's no reason we shouldn't, but it would be as an annotation, and that'd be somewhat, there's some hand-wavy things there about whether that's safe or not. But at the end of the day, you're trying to make a global mapping between workloads, like identity on a particular cluster, like pods within a namespace or pods underneath a service account, back to a global identity in AD. Is that fair?
Well, I mean, the node has the existing identity, but I really see this as being a identity per application that the operator is deploying rather than something that is implicit on each node.
Right. But that mapping exists off the node is what I was kind of implying. It's either cluster scoped or it's in AD, or it's either on Kubernetes in some form as a config map or as metadata on service accounts or in some custom resource, or it's in a mapping that some service is doing between Kube identities and AD identities.
Yeah, so in this case, I wouldn't expect the application to have any dependency on the Kube identity or service account, because what they're really trying to do is map to an existing Windows identity.
Right, and who can map to an identity, right? Can I map to anybody's identity just by going to Kube and saying, hey, I've got this config map. I'm administrator XYZ in group ABC.
Yeah, so I think that it would make sense for the config maps to be constrained down to a given namespace from an RBAC standpoint. I haven't delved deeply enough into the RBAC and namespaces to know if that's possible yet, but I think that would be a goal.
Well, and that means that an administrator on that Kube cluster is able to basically arbitrarily tell anyone in AD. What I'm trying to constrain down is we've talked about this before for Kerberos, and it's a mapping between what a user can do in Kube and what the administrator of AD wants to allow. And so we just, I usually talk about it as a mapping between, some set of Kube identities to some set of AD identities. And that mapping could be as simple as the node. And when we talk about this for Vault and some of the other cases, it's the node needs to go out and ask a particular identity before it goes ahead and allows that mapping to happen. Don't let, if I see a pod from namespace X that's asking for identity Y, somebody has to make the decision to allow that. So, in the CRI, even in the Docker shim or below, that could very easily be a mechanism to call out. That could be that's at a very low level where you're trying to map something fundamental about the container runtime to something fundamental about the cluster without the user necessarily, the user's not telling you, the user's suggesting, somebody still has to validate that the mapping makes sense.
Okay. And you're saying that the validation should happen at which level?
Well, the only real touch point we have in the kubelet is either things like flex volumes, or at the CNI boundary for networking, or at the CSI boundary for storage, or at the CRI boundary for runtime. And so we really haven't talked a ton about how to extend CRI, but for instance, on Windows, the Docker shim on Windows is going to be talking to the Docker that your team knows about. It's certainly not impossible that this might make sense as part of that mechanism, which is whether it's extending CRI or it's something that allows you to say, I have one last chance before I set up the container to make additional settings that are closely coupled to the machine, but also to the information that I'm getting from the kubelet before I stop, before I kind of tear apart the pod info and turn it into OCI container info.
I see. Yeah, so I mean, I think some of that logic could be basically done in the kubelet today, but that would require maintaining those mappings on the machine itself. And that's something that I'm actually trying to avoid, because we've had problems where, as people are adding, new nodes to clusters and things like that, in the Docker model, all these JSON blobs had to be deployed to each node, and people were forgetting to deploy them there. So, putting that information on each node was an impediment that didn't, it hurt usability, but didn't actually help security in any way. It was sort of done as a workaround because Docker was.
Yeah, and it doesn't.
Yeah. Go ahead.
Yeah, I wasn't implying that the information, the mapping had to live on the node, just that the bit of code that sets up the containers is really the lowest level interface between the host, the container, and the pod.
Yeah.
And, if you store this as a config map for a mapping, or whether this is something you look up in AD, or, whether you look up in AD, whether the requested identity has a mapping, from AD to a namespace in Kube, you could do that as a remote call, with cacheability. I know that people really haven't thought about extending the CRI, but to be honest, it is an extension point to Kubernetes very deliberately. And so, there's certainly some weight to be made that we should make that extensibility at least flexible, or, it could just be a property of the Docker shim on Windows. It sounds like a fairly fundamental feature to map, host identity. So I'm not even sure that there's an argument that it shouldn't just, something we could put as part of the Docker shim.
I kind of wanted to ask Clayton's question, but at a higher level. What's the access control story in kind of a multi-user or multi-tenant environment? It sounded like Clayton was assuming that you'd have some namespace to AD identity mapping, but I don't know if that was implied or if you said it and I missed it.
So I think the namespace to Active Directory identity from an operator standpoint, I think that may be a concept that's there in OpenShift. Is that true, Clayton?
I mean, we have a couple of those mappings. To be honest, in Kube, we had always intended service accounts to be the entity that ties a pod identity to something else, but nobody's really ever explored past that today. Like, service accounts have RBAC, and they have, with the stuff that Mike Denise has been working on, they'll have the ability to get tokens for just themselves. But OpenShift never went further than just mapping a small amount of data to namespaces like that. I think I'd be interested in the broader question of, for applications running on Windows, is it an AD to a service account? Is it an AD to a group of service accounts across many namespaces, because applications span many namespaces?
Yeah.
Is it, groups within groups, like a service account, as Kube sees it, might be part of several different components of an application, and there's value in overlapping identity?
Okay. So I guess, so as a next step, do you want me to sort of, explore a few different use cases of what those would look like? Or, 'cause I know we're getting short on time here. So, I mean, do we want to continue this discussion, or do you want me to sort of, or, should the two of us, refine this a bit and then talk about it again in 2 weeks? Or I guess, how do you want to proceed here?
I mean, if others want to have a follow-up on this, I mean, I think the Kerberos and, anything that's a system identity where a much stronger concept of node tied to workload identity. I mean, it's a good topic for this group, but if we maybe want to have a little bit more focused discussion and walk through some options, I mean, I'd be interested if there's others on the call who'd like to join us, for sure.
I'm sorry, who was talking just then? So it was Clayton and who else?
This is Clayton.
Oh, okay.
You're more than welcome to come back in 2 weeks and discuss again here for sure. And in the meantime, if you want to set up separate meetings, go ahead. I think I'd also like to consider rephrasing Clayton's question as if I compromise the node on and it has access to a low privilege service account, how do I prevent it from? I think it's the same question. How do I prevent it from accessing, like rewriting credential spec and accessing a high privilege service account? Is that the same kind of concern?
Yeah.
Right.
Yeah, and in that case, you know, separately in an Active Directory, we get to pick which nodes have access to which service accounts because there's ACLs on that service account itself. So I think that if people had higher privileged service accounts for different services like payroll, they might even consider running those on a different set of nodes for compliance reasons.
I'm not really concerned about node compromise exactly because the node has access directly to credentials by having credentials in Active Directory. But I would like to have an answer on how do you authorize a user to tell the node, I want to use this specific service account. If I have two users trying to run pods, and they shouldn't be able to ask the node to use service accounts they do not have access to. So how do you prevent user A from telling the node, I want to use users B service accounts today? That's I think is the main question.
Yeah, no, I think that's an important one. And it's like likewise, how would I prevent someone from being able to run a container as root? Like where is that authorization check done today? Because I think it would need to be a similar mechanism.
It sounds slightly different, but I'm not sure it's the same.
I think Clayton mentioned that we had started tying things to either service accounts or namespaces. Today, the authorization check of if you can run as root is if you can run as a specific service account where the pod security policy allows that service account, workloads running under that service account to run as root. I guess how we've done policy like that today is associating these checks with Kubernetes service accounts. If a Kubernetes service account can, make use of a security policy, then anybody who can create pods running that service account, which is a namespace check, or create pod in a namespace, is able to assume the privileges of that policy.
Right, having these or Windows credentials back into a PSP would have made more sense to me. So I'm trying to understand why, the proposal is to leave it as a secret rather than, like, for example, a PSP.
Sorry, what was that? You said a PSP?
Yeah, I would have expected the Windows credentials back, to be associated with a PSP rather than,
pod security policy.
Oh, okay.
Okay, I think Mike's next up on the agenda. I think we might move on to the next topic. Mike, do you want to?
Okay. All right. Thank you. Yeah, I'll dig into those.
Thanks for the discussion. That was very interesting.
Yeah, this current thread of conversation curtails very nicely into what I wanted to talk about, which is policy and how it overlaps with external identity. So we have currently pod security policy and a new policy that is under design right now called scheduling policy. And both these associate upper bounds on what pods can specify in their pod spec, essentially. And the mapping between a pod and a security policy is kind of indirected through the Kubernetes service account that the pod is running as. So you say pod security policy is allowed to be used by this service account, scheduling policy is allowed to be used by that one, and those policies are applied on the pod at admission time. So we've kind of discussed how potentially external identities map or don't map to Kubernetes service accounts. One model is to associate them maybe one-to-one or many-to-one, or have them be on completely separate planes of existence where maybe I have, I totally choose to ignore Kubernetes service accounts and run everything in my default namespace, and they're all running as different managed Windows managed service groups, or sorry, I forget the term. And in that model, does the usability of all the other features that we've associated with Kubernetes service accounts break down? So this is kind of something I've been trying to wrap my head around for the past couple weeks, trying to decide what the best thing to map to associate external identities to. Does anybody have thoughts on that? Does everybody understand kind of the issue that I'm trying to describe, or should I clarify anything?
Do you have anything written down?
Not yet. No, I don't.
Okay.
So, for example, what if we specified managed service groups on a pod? So I say this pod, it runs as a specific managed service group. But what happens when I want to say that only these nodes should be able to use this managed service group because it is highly privileged?
Yeah.
Well, the only way to specify these pods must run on these nodes is through a security policy, which is associated through the Kubernetes service account. So logically, the way to make these maps line up is to associate the managed service group with the Kubernetes service account rather than specifying it directly on the pod. Or we can figure out how to associate policies with things that are not Kubernetes service accounts. That's the second option.
So one of the things that concerns me, Mike, and I'm not sure how this fits into your thinking, is that it's always bothered me that we have this sort of one-to-one association between service accounts and pods. Mm-hmm. You know, especially as we start looking at interactions with external systems, like things don't always map as clean as you'd like, and so that one-to-one nature may bite us in the butt.
Right.
The one-to-one in which way? Like which side of the one is problematic?
Oh, okay, so first of all, like one service account, a pod can only be associated with one service account. So it's this model of like, is the pod running as that service account, or does the pod have access to that service account? And if you view it as having access to the service account, then having access to multiple service accounts is a reasonable extension of that. If you view it as running as the service account, then the one-to-one thing actually ends up being more natural. And so I think there's just a slight sort of difference in thinking there. And then there's the issues that we've talked about in the past around exposing service accounts to individual containers within a pod and being able to break things down a little bit more there. And then finally, and this is all, you know, just issues with service accounts. There's the issue of like, do we want to have a separate service account per container per pod for things like daemon sets to be able to actually sort of scope the blast radius for daemon sets that have to talk to and do something serious, right? This comes out of the flex volume discussions we had several weeks ago.
Joe, on that last one, you know, we talked about scopes on the tokens. Do we need separate service accounts for completely disjoint permissions, or would a scoping mechanism be just as good for that case?
Well, I think, you know, this also comes down to what is the nature of identity, right? Is identity including the scope or not? It's like,
who am I?
Yeah, I know, right? Because like, I think, the more complex you make identity, the more complex you make the set of claims that are going on, the more likely it is that folks will get it wrong, right? And so if you had like a service account as a string, and you have a separate string for that service account on a per pod per container basis, then it's going to be easy to screw that up. If it's a set of claims that you have to check in addition to that identity, then it gets a lot trickier to pass that stuff along. So I don't know if there's a right answer here. So and this is not the place where I'm necessarily a deep expert.
But Joe, I think you were an advocate from decoupling external identities from the Kubernetes service account identities from pretty early on, and not having some like indirection through a Kubernetes service account to get access to a external identity, correct? They should kind of live in a flat plane rather than have everything attached to the Kubernetes service account.
I think so. I mean, when we were looking at Spiffy, I was viewing it as there's multiple ways to actually map Spiffy identities into Kubernetes. I think service accounts is one way to do that. I think that it's not necessarily the only way to do that, and I don't think there's necessarily a one size fits all. So right. I think tying those, I think it's a convenient place to start for a lot of scenarios, but I don't think it's necessarily the final place, because as we look at things like the flex volume type of stuff, right, there's questions there. The second issue there is one of I have my doubts to how useful service accounts are as you scope them more narrowly than the namespace itself. I think we have so many confused deputy issues with controllers that creating sub accounts within a namespace is a little bit of a fool's errand. So the namespace is the thing.
I would agree. Like 1 to 4 service accounts per namespace is about where we should stop, and separating namespaces is the much safer thing for lots of reasons, like individual quota management and policy control and et cetera.
Yeah, and I can see cases where you may want to map multiple namespaces, multiple service accounts to a single external identity. So it's not a one-to-one thing there. I just feel like there's not going to be a one-size-fits-all mapping here between Kubernetes objects and external identities.
Right. Well, so that's kind of what I was trying to drive at. How, in a model where we don't use the Kubernetes service account to attach external identities, do pod security policies and scheduling policy work? Because right now they are you attach these to Kubernetes service accounts.
Honestly, I don't have a strong opinion on that stuff yet. I haven't thought through all the implications.
But yeah, so that's kind of the thing that I'm trying to wrap my head around. If it does the user guide of these features that we're rolling out break down, if people are using external identities that are not associated to Kubernetes service accounts.
I might expand my previous statement, which is if you have more than 3 or 4 different policy factors acting on something, and they're combinatoric versus intersecting, then reasoning about them becomes extremely difficult. And so we have the namespaces concept specifically as a way of reducing cognitive load around what different things apply, because humans aren't great at thinking about complex things interacting in a complex way. So you could maybe make the argument that if you have 3 scheduling policies and 4 service accounts, you have 12 possible outcomes. And if you add 2 different quotas to that, you have 24 possible outcomes. And the right solution is break your thing up until you don't have that combinatoric. And if your use case is combinatoric, then you're the super smart person who should be doing it, and everybody else should just be creating more namespaces. So, and I know Quentin's trying to destroy namespaces, but I think that's a long shot.
I think the question here is like, so if I want to have sort of my one identity system, and maybe it's Spiffy, maybe it's Google, maybe it's Microsoft, maybe it's whatever, that I want to have my one identity system, and that's where I want to reason about my identities. Is the identity kind of represented in Kubernetes essentially just like a disk that I attach to pods and I use it to call APIs? Or is it like a fundamental thing that I can, make pod security policy reference that identity? I can make scheduling policy reference my Google identity or my Microsoft identity. And it seems like the only way to do that at the moment is to like attach it to the service account, because that's where all those other things are living.
And that feels very monolithic too, right? I mean, like, and it's tough because it's like end users appreciate being told there's one way to do something. And so if we have like 3 or 4 concepts like identity and policy that line up, there does seem like there's value in lining them up. But at the same time, you don't have to give service accounts connections to other systems. You can give them a secret or a credential. And then the gap does come down when, you want to move beyond giving them a secret. Like, it really always comes back down to secrets for the external stuff. So you're still gonna have to control access to what kinds of, like, somebody has to build an integration with Cube and map Cube concepts to their concepts. We have namespaces, we have labels, and we have service accounts. You got to pick one of those to integrate with. And do we want people always using service account or not? Or most of the time using service account or not?
So I think this is why I like the idea of, we give somebody access to an identity. They don't run as that identity. Now, this is complicated with the fact that with Windows, you really are running that identity. And it seems like the SID stuff in Windows is really more like a UID in Linux, right? And so there's this question of how do we actually make the UID stuff be, which is more complex in the Windows world. How do we actually map that into this world? I think, yeah. Referencing back to the previous conversation.
The original OpenShift UID to namespace mapping was specifically as a poor man's thing to put in place until we figured out how to go map Linux UIDs to external identities. And 11 releases later, we're slowly like talking, but like the whole reason that workaround existed in security context constraints that aren't in pod security policy of the range mapping was specifically to give us a workaround until such a time as it was possible to tie a Kerberos or AD identity to a UID for a pod somehow.
For what it's worth, with Borg and with Google, the closest mapping for like a namespace is really an identity. A namespace and identity are conjoined. And the UID on the individual machines is defined by that namespace. And so the number of namespaces that you can have is bounded by the number of UIDs, and it's just a global mapping across all of Google production.
Which we kind of emulated, but in the real world just gets annoying for a lot of little reasons.
Oh, so, I don't doubt it.
But I'll say that this, in all of the largest customers I've seen in the world, banks and people who've deployed Kerberos at scale and use it, and maybe like Simo knows much more than this about me, but like in my experience, most people do some mapping of some form like that. How close they get to the true one-to-one ideal or not is a matter of how far they've gone. But the biggest, most successful systems basically have that mapping, but it's also a lot of complexity and integration with AD. And that's hard to give to the 99% of Cube users who don't care about any of that today. Because everybody just runs as root in their Docker containers.
Well, that's a separate issue we have to take care of.
Yeah.
So, Mike, I'm not sure if you were hoping for a definitive answer there, but I don't think we have one.
Yeah, I think I need to. I'll try to write down some thoughts in an issue and circulate it. Maybe we can talk about this again sometime soon.
It would be useful, Mike, to the original service account proposal has some of these thoughts in there in a very we haven't written Kubernetes yet, and so we're just kind of like taking shots in the dark based on what we know from previous systems. It would be interesting to, concretely look at the original service account proposal and see what languages and concepts there have held up or can transfer.
Yeah, that's a good suggestion.
Okay.
I mean, it's almost like thread necromancy because it's 3 years old at this point. So
I think we're out of agenda topics. I'm just going to mention the new time slot. There's a voting mechanism there. Please vote if you haven't already. And kind of if you already voted once, I sort of added more times if we wanted to do the off week from where we are currently now. So yeah, please vote, and we'll give, I don't know, maybe we'll give that another week to get the quorum in there. And I think we probably want to cancel the next meeting. It's KubeCon EU. What's the consensus there? Do we want to keep it or do we want to cancel it?
I have no idea.
I'm not going to be around, so I vote for cancel.
I vote for cancel.
No significant objections. All right. Well, let's cancel the next meeting, and then whatever time slot we decide on in that voting will be the one after that. So yeah, please vote. Anything else anyone wanted to say in the last 7 minutes?
Sorry, where's this vote? Is it on the Google group or?
It's in the agenda. There's a link to it.
Oh, okay. Okay,
It's
I'll check.
Yeah.
Yeah, I looked at the agenda, I guess, before it was added. Thanks.
Yeah. Okay. Thanks, everyone. Bye.